Good morning. I'm Bob. Unlike a lot of the discussions here, this is about Visum. I don't know whether many of you have heard about it. It's an urban modeling tool, or that's how I always explained it there. So we actually have a number of studies here that we have built using existing models. More after the model was developed, we didn't have the budget to build a new model and so forth. And I'll explain our experiences with them. Now I've explained at these user groups before how we've used the Visum model to do a number of LOS evaluations, essentially, pretty much looking at the intersections using the ICA or the HCM. We can do a lot of evaluations and what ifs pretty quickly with it and explain what those are. But we've actually had the needs to look at other things or after the model is developed. One thing we have been doing on almost every model now, whether it's included in the budget or not, is actually adding in crash data. Just X and Y location, overlaying it over the model. We can do crash rates and so forth. It can help to highlight locations where we have problems with it. It's pretty quick, easy. It's actually been used on grant applications. This is individuals walking along the road that were either severely injured or killed, and so we can see those locations and report them, and again, readily available here. We've also used it in network identification. You know, usually with Visum models, you know, they're long-range planning, looking at just the classified network and so forth, and usually the client has already established what that network is, its collector streets and above. Well, great, but then we start to examine it, and if we include OSM, you know, which is great having those maps in Visum now. However, we can actually look at other locations that maybe we should have some other network there because it is being used, and we aren't going to go out and just count that data with, you know, it's the old question of we don't know what we don't know, and so just using the crash location data has been very helpful in helping us to understand what we haven't known. You know, that it might be places we would never really look at it. This is one other one. This was an existing model, and you know, looks a little crude there, a little sticky. And they wanted to evaluate a complete streets through here. Now, of course, not a lot to spend and so forth, but so we actually wanted to enhance the network a little bit. Here's the old one, here's the new one. To include the alternate routes, I did not include the background here because I thought we had enough to look at as it was. However, we added in more network nodes, links note that in these Visum models we include all of the intersections and controls and so forth, geometrics, and so we can do the LOS analysis there with the ICA. Also made heavy use of connectors here that ideally, of course, we could split zones up and have connectors in and so forth. But then there's the question of land use forecasts and other things and questions with it. So use the option in Visum of multi-point assignment that, as a lot of you may know, that's near and dear to my heart there. That was an old one we'd established years ago. So just adding it, but then we could look quickly at the changes between the volumes, what would happen with and without our complete streets treatment there, adding in the roundabouts and the slower speeds and so forth. Now, I'll readily admit that the visualization of this is not as nice as watching moving cars, but it still had sold well enough that it happened. So then one other one we have had recently was along a route here. There's a university right in here and so forth, but this is really the only north-south route. They had done a complete streets treatment there, added in channelization for left turns. After it was built, the residents weren't very happy with it because they were weaving in and out. They had the parking in and out, left turn lanes, and delays had increased quite a bit there also. Well, they wanted an evaluation of, do we have to keep this as it is? What will work in 2040 here? And so, like with the earlier one we already had, it was an area that had a model. We added in the other streets there, network, and so forth, which was pretty quick to do. Then of course adding in more connectors here. Now the question is, with all of these access points from these zones, that's pretty wild there, looking at how to distribute those percentages to each connector. We actually started out with all of them equally iterated through, looking at the counts, see where we were high, low, so forth, looking at the underlying land use, again with the aerial and the OpenStreetMap behind it. We could adjust those percentages. Growth wasn't expected that it would be that large. Also, these zones were still small enough that we didn't have the issues with intrazonal assignment, essentially. You know, that really by having more zones versus just having more connectors, that you may have the question of should those intrazonal trips be assigned, but because you know, these are small enough you can still walk across the zone and so forth, that was not a worry there. Now on this model also, there was a question on this corridor of the site distance at locations. They were looking at changing their ordinance, and so we actually added in crash data to it and so forth with the lot lines, so we could see where we may be experiencing issues and where their ordinance may need to be updated as well. And so we could actually very nicely with Visum, we could see locations where it had been adjusted with those lot lines and so forth to improve that, which was pretty interesting to me there, and wanted to share that. Okay, this was the land use growth. We could show them, you know, well, you know, it's not really growing that much and so forth. And then we could look at the what if scenarios pretty quickly and easily with the client. Actually, what was interesting with it is unlike many areas, the AM was worse than the afternoon because of the schools there and the peaking characteristics of the area. I actually had not expected that, but it actually, whoops, excuse me, I meant to hit the arrow back up there. Okay, that actually we had improved operation in this corridor by removal of those left turn lanes at the intersections. And the problem really was the intersection timing, that it was state controlled, and so they had very long amber and all red times and had exclusive left phases and so forth. A lot of lost time there required with those lanes, whereas removal, traffic wasn't that heavy, wasn't going to grow much. Plus, there was this alternate route being built by 2040 also, which helped us as well. And so we could recommend changing those left turn lanes into bike lanes, or using the space as bike lanes, doing actually a little more calming instead. Okay, one thing we did here, you know, that those of you who work with the HCM, you know that with most of the intersections, you use average LOS. For stop signs, partial way stop signs, you use the worst turn LOS. And to have those plots here or graphics with the LOS reported out, we at last got smart enough just to add in a little statement, just ask if it's the two-way stop, use the worst turn, or if it's not, use average with that graphic. And instead of having one for each, that just made it a little easier there. One other thing that we did is we renumbered the nodes for the LOS analysis, because with the output it always reports them in node order. And so we just changed the numbers. I mean, it's pretty simple. Just to have them in the alphabetical order or the order that we wanted, we just renumbered those nodes to make that easier. Okay, here was one more that this was one area here that this is an old state highway. It gets a lot of through traffic because the major interstate down here has not been extended like it's been planned for a long time, but it's now developing, and there's apartment buildings and other stuff going in on this one corridor. This was identified years ago. The model had been built years ago, but they were looking at adding in some other network both east and west of it to help relieve that a little bit. That we analyzed it with and without. I apologize, those don't line up, and it's a little hard with the aerial to actually look at it, but we still had some LOS problems. The average worst turn here, you know, it improves it a little bit, but we were still having problems. Then looking at the crashes with it, you know, and the question of, well, when are those crashes happening? Well, interestingly enough, it's the peak hours. So it's an issue with access management. We actually engaged the individuals in the area, the ones that owned the property. We made plots to use in our meeting, and it's a little hard to see here, but we actually plotted all of the crash locations. Again, used it to identify in the model where significant driveways were. So although Visum is a macroscopic model, using it as a more microscopic way, again, because it was the tool that we had, then we could use this in the meetings, spread them out on the tables and so forth, discuss it, you know, that we've had discussions how the public is much more educated now. They can look stuff up on their own. They will look up stuff. They've got better ideas. I've been in enough public meetings also where I don't think the agency or consultant is listening. So we went in, we were just explaining, used a lot of the materials available through FHWA to explain the ideas of conflict points and so forth. We said, let's use that as a strength. Let's educate them a little more, hand it out, the handouts that are available through access management, FHWA, explained the idea of left turns being our major issue on that corridor there, number of access points, but engaging the property owners, letting them know. Gosh, it would have been nice to have the movies though, you know, instead of the book. and then had them actually write notes where they own it, their ideas and so forth. And so actually with this project, we're still compiling the ideas before we run our what if scenarios there. But what had hit me after that was that we can actually, within Visum, we can actually plot with the chart option the locations where we have the highest number of left turns at the stop signs, essentially. And although we have worries on this corridor, which correlates well with where our crash locations are, we have some other analysis ones that maybe, again, we hadn't identified before, and we didn't have the crash data for those locations off of that corridor. But those are ones that if we look at the future, we have, even with the other improvements, we have a large number of left turns that we should look at with this project also. With it, any questions?
I just want to make a comment. I mean, it's pretty impressive that a lot of that was in Visum and all done within software with the crashes and then just the comparisons.
Thank you. Yeah. Well, what was nice is we already had Visum models, or others had them in those locations, and so it was easily adaptable for a low budget. So we could quickly explore those.
Yeah. And it just speaks to expanding your model beyond just the core corridor, the core study area, where you can find some of these other issues. Yeah, there's a question over here.
Go ahead, Mr.
Oh, yeah.
Have you looked into like matching up the traffic volumes with the safety analysis to really develop like critical crash rates and be able to use Visum as a tool to identify where those critical crash rates are? Those models?
We actually have in other studies before, but had not here. Jim?
Who's the picture? Who's that in the picture there?
It's those darn shorts that I sued. Yeah. That was a long time ago. Long time ago.
Yeah.
Okay.
Yeah, thank you.